just underneath the stomach, starts to release a hormone called insulin. And it's insulin that helps our body get the energy from the food we eat. The bloodstream then takes the glucose and the insulin to every cell in our body that needs it. To make this easier to understand, let's look at muscle cells. At the muscle cells, it's insulin that allows the glucose to get into the cells where it can be used for energy. It's a bit like insulin is a key unlocking the door to the cells, so the glucose can get in.
So if you can kind of look at this, the cells are lined up side by side, and the cell's outer covering for us is the cell membrane. And the cell membrane actually has gaps in it, allowing things to pass in and out. It's not actually shaped like an eye. There are multiple gaps or pores throughout the entire cell membrane. So as the glucose, which is actually larger than any of the openings leading into the cell, tries to get in, it can't just pass through these pores by themselves. It needs assistance to get in. So insulin, which has been released by the pancreas, goes with the glucose to the cell. The insulin attaches itself to the outer section of the cell, which then makes room. The cell's membrane makes room so that the glucose can get inside. So that's why we need both insulin and glucose going in at the same time to help get this glucose inside. And glucose is actually the molecule that we use for fuel. If you can imagine trying to drive a car and there's no gasoline in the car. You can take the gasoline and pour it on top of the car all you want. If it's not in that tank going to that engine, it's not going to do you any good. So it's not important just that you got the energy molecule inside your body. It needs to be in the right location so that it can do its work. Continuing.
That way, the blood glucose level starts to drop. But the blood glucose level can be topped up at any point by the liver releasing extra glucose that it has stored. The blood glucose rises again, and again the pancreas produces.
The liver releases glucose. You eat food that contains carbohydrates, I'll go into that tomorrow, and you're going to get glucose. So there are two basic places where you're getting glucose from. The food that you eat, if you are not using the energy molecules that's in that food at a given moment, the body doesn't just discard it. The body, these pillars I mentioned, the body actually stores glucose in the event that you run into a position where you need it. Let's say you're stranded somewhere and you can't get any food. Let's say that you are intentionally backing down on what you eat, like dieting, fasting, etc., and you're not eating certain things and your body needs energy just to do its basic activities. Well, the liver is the place where the body goes to get that energy from. When the glucose gets stored by the liver, it gets transformed into fats. The liver holds the molecules of glucose in the formation of fats. When your body is starving and the muscles tell the body, there's signals that the different parts of the body sends out to other areas to tell the body when there's a problem, when there's some difficulties, when there's a need for something to change. So if the muscles say we need more glucose and it's not in that person's stomach, it's not in their intestines, it's not in their blood, then the signal goes to the liver and the liver converts that fat into glucose and releases it to the body. I didn't say when the blood said that we need more glucose, I said the cells. So if you are actually in a situation where the glucose is staying in your blood, your cells are still without. The cells are sending out a signal. The liver says, hey, I'm going to give this glucose to the body. Now you got an extra dose
to move with that glucose through the bloodstream to the muscle cells, open the doors and let the glucose in. The body functions best with the blood glucose at an optimum level. It doesn't like it if the blood glucose rises too high. Normally, there's a cycle within the body which balances out the glucose
and regulation that Allah does,
and this is achieved by the food you eat, the pancreas and the liver. However, in some people, the system doesn't work properly and they develop diabetes. There are two main types of diabetes, type 1 and type 2. In type 1 diabetes, the body isn't making any insulin at all. This is because of an autoimmune response whereby the body has destroyed the insulin-producing cells in the pancreas. We don't entirely know why that happens in some people and not in others. Type 1 diabetes accounts for about 15% of all cases. It's most often found in the under 40s, and it's by far the most common type of diabetes found in childhood. In type 1 diabetes, the carbohydrate-containing food is broken down into glucose as normal. That glucose then moves into the bloodstream. Normally, the body would produce insulin to let that glucose into the cells, but in type 1 diabetes, there is no insulin being produced, so the glucose can't get into the body cells at all. So the level of glucose in the blood rises and rises. The body tries to lower the level of glucose, tries to get rid of the glucose through the kidneys. That's why people who have undiagnosed type 1 diabetes tend to go to the toilet a lot to pass urine. As the kidneys filter the glucose out of the blood, they also take a lot of water with it, so the person with diabetes will get very thirsty. The urine contains a lot of glucose, and that creates an environment where it's quite easy for bacteria to thrive, so it's also quite common to get thrush or genital itching. In the same way, the blood contains a high level of glucose as well, so more bacteria than usual will tend to breed in flesh wounds, and they might be slow to heal. Glucose can also build up in the lens at the front of the eye, causing the liquid in the lens to become cloudy. That can mean that some people with undiagnosed type 1 diabetes can have blurred vision. Because the glucose can't get into the cells to be used for energy, somebody who's got undiagnosed type 1 diabetes is going to start feeling very tired, lethargic, and unable to sort of go about their normal daily routine. But the body still needs an energy source in order to work properly. So what it does is it starts to break down its fat stores, and that can lead to weight loss. So the main symptoms of type 1 diabetes are going to the toilet a lot, thirst, thrush or genital itching, slow healing of wounds, blurred vision, tiredness, and weight loss. These symptoms generally happen quite quickly, often over a few weeks, and can be reversed once the diabetes is treated with insulin. Type 2 diabetes accounts for about 85% of all cases in the population. It's most common in the over 40 age group in the white population, and in the over 25 age group in the black or South Asian population. Type 2 diabetes is a little more complex because of slightly more processes at work. Either the body isn't producing quite enough insulin, or the insulin it is producing isn't working properly. That can be due to being overweight because a build-up of fat can stop insulin doing its job properly, but it can also happen in people of a healthy weight. So in type 2 diabetes, the carbohydrate-containing food is broken down into glucose in the stomach and digestive system as normal.
Okay, let me stop here for a second. So they're saying that in a person with type 2, they swallow their food, they've eaten some carbohydrates, they swallow it. It goes down into the stomach, comes through the esophagus, goes down into the stomach like normal. If you are eating something that is pure carbohydrates, and the carbohydrate happens to be smaller structure, smaller molecules, I'll talk about that in more detail tomorrow, there are pores in the walls of the stomach that will allow those carbohydrates to seep out. And they can actually go into the blood system faster than normal. If you are a person who does not have diabetes, and your body's producing insulin correctly, that's not going to be a big issue. So if you eat a piece of candy, if you drink some tea that's got white table sugar in it, you're eating foods with carbohydrates that are somewhat small. The structures are somewhat small. You swallow those, it goes into your stomach, and if that's all that you've eaten, if you've only eaten that piece of candy, if you only had that cup of tea, then you're going to have all of this glucose stuff in your stomach with nothing else connected to it. The stomach's going to do its churning and do all